All right, so our 5.2 notes, we're specifically talking about sine and cosine of our special angles. We're going to use reference angles, identify domain and range of our sine and cosine, and then evaluate cosine and sine using calculators. All right, so this is the beginning of like your TVA, your trigonometric values assessment. All right, so specifically talking about this thing called a unit circle. The unit circle has a center at the origin, 0, 0, and a radius of 1. Okay, in the unit circle, the intercepted arc is equal to the radian. All right, so here is my x and y axis right here. X-axis, y-axis. So each of these points from the center to a side, these all are 1 unit. All right, so we have a pi over 6. So it's saying that the measure of this arc is pi over 6. And the arc is congruent to the angle. And then I've got my pi over 4, and so on. All right, so the key feature on all these is that each radius, no matter where it's at, a radius is always going to be 1. All right, so let x and y be endpoints on the unit circle. Okay, so we have x and y, endpoints on the unit circle. The xy coordinates at this point can be described as functions of the angle. So for angle T, we can label the intersection of the terminal side, so terminal, with the circle as coordinates x and y. So x and y is just you had a horizontal shift, and you had a vertical shift. That's your x and y. All right, now let's talk about where this cosine and sine comes from before we get to the next section. Now we go back to right triangle trig. Let's say our angle is here. Okay, then we know our hypotenuse is 1. Let's say I wanted, okay, well, that's adjacent. Well, the angle, the trig function that gives me the adjacent side is cosine. Cosine theta equals adjacent over hypotenuse, in this case 1. So cosine theta equals simply the adjacent side. Well, that's the x. And our vertical, okay, well, that's opposite. Okay, well, opposite is sine. Sine theta equals opposite over hypotenuse, which is 1. So sine theta equals opposite. That's the y. So cosine is x, sine is y, which is where this next thing comes in. F of t, your x coordinate is cosine. F of t for sine. So x is cosine, y is sine. So I want you to highlight this or underline it or whatever. I don't like the green. Let's do something else. So x for cosine, y for sine. Because x is left and right, your horizontal. Cosine is up and down, vertical, x and y. All right, certain angle, t, corresponds to a point on the unit circle, negative square root 2 over 2, positive square root 2 over 2, as shown in the figure. Find cosine t and sine t. All right, so cosine t equals the x coordinate at our point. So cosine t is negative radical 2 over 2. Sine t is the y coordinate at our point. All right, let's talk about cosine of 90 and sine of 90. Cosine 90 degrees. All right, I need you to remember that this is a unit circle, so the radius is 1. That means this measure from here to there, all that is 1. Well, that's on an axis. And since it's on the y-axis, that means its x-coordinate is 0. Its y-coordinate is 1. 1. Well, if cosine is the x, well, that's 0. Cosine 90 is 0. Sine, well, that's the y. The y is 1. So sine 90 is 1. Okay, find the cosine and sine of pi. Well, pi is over here. Again, we need to consider that the radius is 1. Now, this is left. So this measure, the distance, yes, it's 1, but the x-coordinate is -1. You went left 1. And since it's on the x-axis, its y is 0. So cosine pi equals the x-coordinate for pi. That's -1. Sine pi equals the y-coordinate, which is 0. All right, so we've got this big picture here. Okay, this is our unit circle. But I specifically want to talk about the signs, positive versus negative. So if we're in quadrant 1, that means we have gone right and we've gone up. So our x's and y's are both positive. Over here in quadrant 2, we went left and up. Well, if we went left, our x was negative. If we went up, y was positive. Okay, now we're down here in quadrant 3. We're still going left, but now we're going down. So that's a negative x and a negative y. We're over here in quadrant 4. We went right, but we went down. So right was a positive x, down was our negative y. We have this Pythagorean identity. Okay, Pythagorean theorem, a squared plus b squared equals c squared. Okay, c is the hypotenuse. Okay, a and b are leg lengths. So if we put it on a coordinate, the radius corresponds with c, and our side lengths correspond with a and b. So x and y is a and b. So if we sub in sine and cosine, remember cosine is our x, sine is our y, and our radius is 1. And we simplify this. Cosine squared theta plus sine squared theta equals 1. Okay, I generally use it as sine squared plus cosine squared, but it honestly does not matter. Okay, we use this particular identity quite a bit in unit 6, maybe 7. It's one of those. It's probably 7. All right, now, so if sine is 3 over 7, and sine I just lost my train of thought. Okay, if sine is 3 over 7, okay, well, sine is y over radius. Remember, opposite over hypotenuse, with hypotenuse being r and opposite being y. Then it says cosine is less than 0. So it says cosine is negative. All right, hypotenuse is always positive. Okay, it's a distance. Okay, since your sine is positive, that means I have a positive y. So if we consider where y is positive, that is in quadrant 1 and quadrant 2. Y is negative in this one and this one. So we're not going to use those. Cosine is negative. Well, cosine is the next coordinate. So between these two, quadrant 1 and quadrant 2, well, if cosine is negative, that means the x is negative. So that leaves this, which means our angle is in quadrant 2. And it means x is negative. So let's consider how we're going to solve for that x coordinate. Well, x squared plus y squared equals radius squared. I don't have the x. I do have the y. It's 3. I also have the radius. It's 7. I can solve for x now. Square root. Let's talk about doing a square root. Okay. It kind of depends on how your teacher taught you. Back in it's 1513. I do it with prime factors. It doesn't really matter to me how you do it. The prime factors are 40. All right, so I simplify square roots with prime factors. So 40 has the smallest prime of 2. That's 2. And you keep going until that top number's prime. So then you look for pairs. So a pair of 2s. All right, so what's 2 times 2? It's 4. Then you multiply the other 2 together. 2 times 5. 10. Well, square root of 4 is 2. 10 is not a square. All right, so when you typically do a square root, you have plus or minus. All right, because x is negative, that means I want the negative 2 root 10. All right, so cosine theta equals adjacent over hypotenuse. So that is x over radius. Well, x is negative 2 root 10. Radius is 7. Okay, same type of example. This time I'm giving you cosine. Cosine is negative 3 root 5 over 7. So it's telling you that cosine is negative. Okay, if I think of my quadrants, cosine is negative where x is negative. So that means cosine is negative in quadrants 2 and 3, because in these two, x is positive. But then it says sine theta is less than 0. So that means sine is negative. And if sine is negative, sine is also the y-coordinate, y is negative. Well, y is positive. So that means I'm in quadrant 3. All right, well, cosine is adjacent over hypotenuse. So that is x over radius. I need the y. So x squared plus y squared equals radius squared. So x is negative 3 root 5 squared plus y squared equals radius squared. All right, so this is going to be negative 3 root 5 is going to be 9 times 5, which is 45. Subtract the 45, y squared is 4. So y is plus or minus 2. But since I'm in quadrant 3, y is negative 2. So sine theta. Okay, sine is opposite over hypotenuse, which is y over radius. I have the y. It's negative 2. I have the radius. It's 7. This page right here, this is the beginning of your TVA, your trig values assessment. All right, so we're simply talking about sine and cosine on these. Our special angles are pi over 4, which is 45 degrees, pi over 6, which is 30, and pi over 3, which is 60 degrees. Each one of these, they are related to your special right triangles. Okay, so your 45s come from isosceles right triangles. So in an isosceles right triangle, your leg lengths are equal, so x, Okay, using Pythagorean theorem, x squared plus y squared, so another x squared, equals hypotenuse squared. So this is 2x squared. I just lost my train of thought. Never mind. Ignore that. Okay, this is x root 2. All right, awesome. I have that, though. I know that the radius is 1. All right, well, if the radius equals 1, then x, I must be dividing by root 2. All right, well, if you rationalize, multiply top and bottom by the root, x is root 2 over 2. Okay, guys, if x and y are congruent, that means not only is x root 2 over 2, that means y is root 2 over 2. Okay, so that's quadrant 1. So quadrant 1, root 2 over 2, root 2 over 2. Okay, we've already talked about it. In quadrant 1, x and y are both positive. In quadrant 2, so same angle, this is still a pi over 4 angle, but my signs have changed. My x is now negative, but the values haven't. X is negative, y is positive. All right, now I'm down here at 5 pi over 4. This angle is still pi over 4. That's my reference angle. The only thing that's changed is your sign. In quadrant 3, x and y are both negative. And now I'm on my last one, 7 pi over 4. This angle is still pi over 4. So my point, in quadrant 4, the x is positive, but the root is negative. Or excuse me, but the y is negative. So x is positive, y is negative. Which means I can go over here and say, okay, the cosine of 3 pi over 4, right? Something to get used to, to know what quadrant you're in. If your numerator is 1 less than the denominator, you're in quadrant 2. If it's 1 more, you're in quadrant 3. If it's almost double, you're in quadrant 4. So this is 1 less, 1 more, almost double. Okay, so if I'm 1 less, quadrant 2, x is negative, so negative root 2 over 2. Quadrant 3, x is still negative, so negative root 2 over 2. In quadrant 4, your x is positive, so positive root 2 over 2. Awesome. Now we do sine 3 pi over 4. So these were all x's. Sine is all y's. And the rules are still the same. If it's 1 less, quadrant 2. So 3 is 1 less than 4. 5 is 1 more than 4, so that's quadrant 3. And 7 is almost double the 4. This is quadrant 4. Well, quadrant 2, the y is positive, so positive root 2 over 2. Quadrant 3, y is negative, so negative root 2 over 2. Quadrant 4, y is also negative, negative root 2 over 2. These values don't change, just their signs. So if you know the quadrants, you can figure out the signs. If you understand that it is an isosceles right triangle, knowing that this is 1, and these two have to be the same. So x squared plus x squared has to equal 1 squared. Divide by 2. Square root. And rationalize. There's a whole bunch of things you can do to get these values. You just have to remember that the two sides are the same. They're congruent. And it fits into Pythagorean theorem. So in our second section, our reference angle is going to be pi over 6. These are our 30-degree angles. All right, well, you think back to our special right triangles way back when. 30-degree angles, right? Everything revolves around the short side. So x, hypotenuse is 2x, The side across from your 60 is your x root 3. So that means if I know that the hypotenuse is 1, that means x must equal 1/2, so our short side. All right, so that means on our actual triangle, that means the y is a 1/2. Well, if I know that the y is 1/2, to get my x coordinate, I simply multiply that by root 3. So it is root 3 over 2. So anything that has a reference angle of pi over 6. All right, so reference angle, pi over 6. Reference angle, pi over 6. Reference angle, pi over 6, and then same thing down here. Reference angle, pi over 6. So all of my pi over 6s, anything that's got a pi over 6, falls in this category. So quadrant 1, okay, we have our x's, root 3 over 2, y's 1/2. Go over here to 5 pi over 6, same values. Those values haven't changed. It's just now your x is negative. And your y stays the same. Now we're down here. X and y are both negative. And now we're down at 11 pi over 6. X is positive. Y is negative. Okay, so I'm looking at cosine 5 pi over 6. 5 is 1 less than 6. This is quadrant 2. And I'm looking for the x coordinate. All right, well, x is always root 3 over 2. And in quadrant 2, your x is negative. Cosine 7 pi over 6, that's 1 more than its denominator, so that's quadrant 3. Okay, the x is still the same, root 3 over 2. But in quadrant 3, x is negative. Cosine 11 pi over 6, that's almost double. So this is quadrant 4. The x is still root 3 over 2. And in quadrant 4, your root 3 over 2 stays positive. Which I'm not going to draw in there because it's a positive sign. Okay? Sine. So 5 over 6, so that is quadrant 2. Okay? Sine 5 pi over 6. Pi over 6 has a y coordinate of 1/2. In quadrant 2, sine is positive. Quadrant 2, or your 7 pi over 6, this is 1 more. This is quadrant 3. Your y is still 1/2. But in quadrant 3, y is negative. We've got 11 pi over 6, almost double. That's quadrant 4. It's still 1/2, but your y is negative. All right, so your pi over 6s and your pi over 3s work together. The only thing that changes is the reference angle. So pi over 6, our angle right here, represents you at 30 degrees. Okay, your pi over 6. My reference angle on this one is the pi over 3, which is the 60 degrees. All right, so short side is still 1/2. So short side is 1/2. Long side is still root 3 over 2. Only now, x is 1/2. And y is the root 3 over 2. All right, so in pi over 3, x and y are both positive. So 1/2 root 3 over 2. Quadrant 2, x is negative, y is positive. For all of our reference angles here, pi over 3. In this case, x and y are both negative, so negative 1/2, negative root 3 over 2. Okay, our last one, 5 pi over 3. X is positive, y is negative. Okay, so if you know these, I just have to rotate them around the quadrants. Always going to be 1/2 root 3 over 2 when your reference angle is pi over 3. It's just changing signs. So cosine 2 pi over 3, that's quadrant 2. Okay, cosine is always going to be for 2 pi over 3. For pi over 3 is root 3, is 1/2. I don't know what that is. And in quadrant 2, cosine is negative. Okay, cosine 4 pi over 3. So we've got the pi over 3, so its x is still 1/2. But we're in quadrant 3, so x is negative. 5 pi over 3. X is still 1/2, but you're in quadrant 4, so our x is positive. Sine 2 pi over 3. So sine is always the same, root 3 over 2. But in quadrant 2, that's a y-coordinate, that's positive. All right, sine 4 pi over 3, it's still root 3 over 2. But now you've got that 4 pi over 3, so you're in quadrant 3. And sine is negative, because your y is negative there. Now we have sine 5 pi over 3, so it's still root 3 over 2. But you're in quadrant 4, and y is negative. All right, so on this page, you're filling out, this is a blank unit circle. This is degrees. So you have degrees, radians, ordered pair. So I want you to take probably 3 or 4 minutes, and I want you to fill this out. Okay, if you're watching the video on this, you'll pause once you see it. All right, so if you're watching the video, I want you to pause on this so you can see all the different, I even color-coded it a little bit. So my quadrantals are all in blue. My pi over 6 is green. Pi over 4 is pink. Pi over 3 is orange. Even highlighted. All right, so if you're trying to copy this down, pause it here, copy it down, and move on. All right, so just a reminder, we're going to use our reference angle to help with this, especially if you don't have the unit circle in front of you. All right, so quadrant 1, your reference angle is the angle. Quadrant 2, 180 minus your angle. Quadrant 3 is your angle minus 180. And quadrant 4, 360 minus your angle. We use that to help with, just lost my train of thought, to figure out your special angle. So 135, all right, that falls in between quadrants, falls in between 90 and 180. So I'm going to do 180 minus 135. That is 45 degrees. Well, 135 is in quadrant 2. So the reference, what I'm trying to write, reference angle, 45 degrees. All right, so negative 330 degrees. So in your negative angles, you're going to add 360, so that's going to give you 30 degrees. So this is putting us in quadrant 1. $240. Okay, that's in between 180 and 270, so I'm going to do 240 minus 180. That is 60. That's putting us in quadrant 3. And as far as your radians go, I'll tell you, because of the special angles, all right, if you have an over 6, your reference angle is pi over 6. If you have a 4, your reference angle, pi over 4. If you have a 3, your reference angle, pi over 3. So your special angles and radians are pretty straightforward. So this is a kind of a reminder. Pi over 6, cosine radical of 3 over 2, root 3 over 2, sine 1/2. 45 is both a root 2 over 2. 60, your x is 1/2, your cosine 1/2, y is root 3 over 2. And then your 90, your pi over 2 is 1, 0. All right, cosine of 3 pi over 4. All right, well, I can use a whole bunch of different things on this. All right, first thing I can use is the reference angle. Because it's an over 4, my reference angle is pi over 4, which means my coordinates are root 2 over 2, root 2 over 2. All right, next thing I can use is the fact that it's cosine. So I'm looking at the x coordinate. Next thing I'm going to use is this is 3. So that is 1 less then 4. So this puts me in quadrant 2. So my x is negative. So cosine 3 pi over 4 is negative root 2 over 2. Sine 11 pi over 6. Okay, it's over 6. So your reference angle is pi over 6. All right, so that's root 3 over 2, 1/2. All right. I want sine, so I want the y-coordinate. 11 pi over 6. That's almost double. Quadrant 4. So your y is negative. So sine 11 pi over 6 is negative 1/2. Okay, sine 240. All right, so that is more, I think I already did that one, 240. Yeah, 240 has a reference angle, 60 degrees. All right, so if it's 60 degrees, my ordered pair is 1/2 root 3 over 2. I have sine, so I want the y. 240 is in quadrant 3, so the y is negative. So sine 240 degrees equals negative root 3 over 2. Okay, 150. So this is less than 180. So I'm going to do 180 minus 150. So reference angle is 30 degrees. So it means root 3 over 2, 1/2. Cosine is x. All right, since I subtracted from 180, that puts me in quadrant 2. X is negative in quadrant 2. So cosine 150 degrees equals negative root 3 over 2. All right. Now, negative angles, we have to kind of watch a little bit. All right. The reference angle is still going to be pi over 6. I see the pi over 6 right here. That's our reference. So root 3 over 2 for x, 1/2 for y. Cosine is x. All right, so now I have to think. It kind of flips it around. All right, pi over 6. This would be negative. Negative 5 pi over 6. That would be your negative 7 pi over 6. That would be your negative 11 pi over 6. So it flips it around. All right, the location of the quadrant is still the same, though. This is still quadrant 2, regardless of whether I went negative or positive. All right, so quadrant 2, cosine is negative. So the cosine of negative 7 pi over 6 is negative root 3 over 2. Okay, and we're going to do the same idea with this one. This is negative 5 pi over 4. So the pi over 4, reference angle, so that's root 2 over 2 for both. Okay, let's consider pi over 4, 3 pi over 4, but negative. So 5 pi over 4 again puts us in quadrant 2. Over here we have negative 7 pi over 4. Not worried about that one. But I'm in quadrant 2, which means your cosine, so then what the x is negative. So cosine negative 5 pi over 4 is negative root 2 over 2. Okay, using the x and y axis to evaluate trig functions. So 180 degrees is over here. Okay, so that means I went left 1, up 0. Sine is the y-coordinate, so that's the 0. So sine 180 is 0. 2 pi, remember that's 1 full rotation. So we went right 1, up 0. Cosine is the x, so that's the 1. Cosine 2 pi is 1. Negative pi over 2, that is down here. So we went left to right 0, down 1. Sine is the y-coordinate. So sine negative pi over 2 is negative 1. All right, so domain and range. Domain is all your x's from left to right, and range is all your y's from top to bottom. So it's basically asking, is there some angle where your sine is undefined? Well, you can see the arrows going both directions. There's not a place where your sine is undefined. So your domain, infinity. Your range is the lowest to the highest. So the lowest possible y value is negative 1. Highest possible, positive 1. So my answers are between negative 1 and positive 1. Cosine is the same idea. All right, you can see arrows at the left and the right. So this goes on forever and ever for domain. And I can see that the lowest possible y value is negative 1. The highest possible is positive 1. So the majority of these notes for 5.2 have been special angles, your 45s, your pi over 6s, your 3 pi over 4s, those things. If you're trying to find evaluated trig functions for something that's not a special angle, so it's not a unit circle value, we use a calculator. All right, so the thing I want you to watch for, and I need you to highlight this, is check the mode. Okay, you need to be in the correct angle measure, degrees or radians. Well, how do you know which one's which? Radians have a degree sign. Or, listen to that. Degrees have a degree sign. So degrees have a degree sign, radians don't. So this first one, radians. I don't have a degree symbol. Sine 22 degrees, that's a degree symbol. Sine squared of 3, that's radians. I don't have a degree symbol. Cosine squared of 94 degrees, degrees, because I have a degree symbol. Okay, so I'm going to do the two that are in radians first. So cosine of 3.7. Go to your calculator. Okay, find the button that says mode. Okay, mode is right next to my second button. And you want to make sure radians is highlighted. My radians is highlighted. Awesome. I hit second mode. And I forgot what it was. Cosine 3.7. I was really just making that up. I have no idea. So cosine 3.7. Okay, negative 0.848. So a couple things to notice is that the parentheses, if it's just straight sine, cosine, or whatever, you don't necessarily need the parentheses. You can have them, but it doesn't change the value. Where it does is when you start having powers of trig functions. All right, so if I want to take a cosine, evaluate it, and then square it, I would write it as cosine squared x. Problem is your calculator doesn't do that. So we have to use the double parentheses for the calculator. All right, so I have sine squared of 3. This means I'm taking the sine of 3, squaring the result. So when you do that in your calculator, you want to do parentheses, sine of 3, close the sign, close the function, square. So 0.019, so 0.020. All right, so now we're in degrees. So sine 22 degrees. I'm going to go over into my calculator. Mode. Scroll down. Highlight degree. Enter. Second quit. So sine 22 degrees. Sine of 22. Okay, I'm in degrees, so this should be okay. So this is 0.375. And again, parentheses, you can have them, not have them, it doesn't matter here. Where it does matter is your powers. Cosine squared of 94 is really the cosine of 94 degrees squared. Since I'm putting in the calculator, I need the double parentheses. parentheses, cosine 94, close the 94, close the cosine, squared. So 0.005.